But now it's time to start this space and rocket review. Just after a quick
Discovery,
intermission.
go and throttle up.
Let me just switch that off of gaming to science and technology. There we go. Run ST on both sides. Okay, cool. I have a video for you to watch. I will be back when this video is done.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the Sun at one focus and the other focus empty.
Applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
the line joining the planet to the Sun sweeps over equal areas in equal time intervals.
When a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the three Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a three-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by 3 orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, The time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch, measured eastward from due north, is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the Space Shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The Space Shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 Space Shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system referred to as ohms are required to place the orbiter in its final orbit. The ohms 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The ohms 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of two burns and is used to accomplish an orbit transfer between two circular orbits in the same orbital plane. The most energy-efficient transfer between two orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes. Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the space shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
All right. What'd you think of that? Pretty good, right? All right. So, you understand orbital mechanics better? Neat. I shall grab lunch. You'll understand the fundamentals of spaceflight. All right. Let's get those space news links teed up here. I got a couple. Okay, there's that. We talked about Frame 2 yesterday. There we go. Okay. Let's see. You know, I used to drive by the Saturn V about 3 days a week. I think I know a thing or two about spaceflight. Oh, yeah, man. You're an expert. Okay. The news cycle is not... It's not very big today. There's not a lot. So we'll probably be playing Satisfactory sooner rather than later. What was the deal with that tweet from SpaceX on the Boca Water stuff? Oh. Well, let's go find out. Okay. All right. I guess SpaceX chose to be spicy today. Let's dive in. Let's see what we got. This is coming from SpaceX Actual. All right, what do we got? CNBC's story on Starship's launch operations in South Texas is factually inaccurate in bold text. Starship's water-cooled flame deflector system is critical equipment for SpaceX's launch operations. It ensures flight safety and protects the launch site and surrounding area. Also known as the deluge system, it applies clean, potable, drinking water to the engine exhaust during static fire tests and launches to absorb the heat and vibration from the rocket engines firing. Similar equipment has long been used at launch sites across the United States, such as Kennedy Space Center and Cape Canaveral Space Force stations in Florida, Vandenberg Space Force Base in California, and across the globe. SpaceX worked with the Texas Commission on Environmental Quality throughout the build and test of the water deluge system at Starbase to identify a permit approach. TCEQ personnel were on site at Starbase to observe the initial test of the system in July 2023, and TCEQ's website shows that SpaceX is covered by the Texas Multi-Sector General Permit. When the EPA issued their administrative order in March of 2024, it was done without an understanding of basic facts of the deluge system's operation or acknowledgement that we were operating under the Texas Multi-Sector General Permit. After we explained our operation to the EPA, they revised their position and allowed us to continue operating, but required us to obtain an individual permit from TCEQ, which will also allow us to expand deluge operations to the second pad. We've been diligently working on the permit with TCEQ, which was submitted on July 1st, 2024. TCEQ is expected to issue the draft individual permit and agreed compliance order this week. Throughout our ongoing coordination with both TCEQ and the EPA, we have explicitly asked if our operation of the deluge system needed to stop, and we were informed that operations could continue. TCEQ and the EPA have allowed continued operations because the deluge system is always compiled with common conditions set by an individual permit and causes no harm to the environment. Specifically, we only use potable water in the system's operation. At no time during the operation of the deluge system is the potable water used in an industrial process, nor is the water exposed to industrial processes before or during the operation of the system. The launchpad area is power washed prior to activating the deluge system with the power wash water collected and hauled off. The vast majority of the water used in each operation is vaporized by the rocket's engines. We send samples of the soil, air, and water around the pad to an independent accredited laboratory after every use of the deluge system, which have consistently shown negligible traces of any contaminants. Importantly, while CNBC's story claims that there are very large exceedances of the mercury as part of the wastewater discharge at the site, all samples to date have in fact showed either no detectable levels of mercury whatsoever, or found in very few cases levels significantly below the limit EPA maintains for drinking water. Retention ponds capture excess water and are specially lined to prevent any mixing with the local groundwater. Any water captured in these ponds, including water from rainfall events, is pumped out and hauled off. Finally, some water does leave the area of the pad, mostly from water released prior to ignition and after engine shutdown or launch. To give you an idea on how much, a single use of the deluge system results in potable water equivalent to the rainfall of 0.004 thousandths of an inch across the area outside of the pad, which currently averages around 27 inches of rainfall per year. That is a tenth of a millimeter. What's below millimeter in metric? I don't remember. Yeah, so right? Yeah, absolutely. Yeah, 0.1 micron. Micrometer. Yeah, there you go. Yeah, it's nothing. Yeah. With Starship, we're revolutionizing humanity's ability to access space with a fully reusable rocket that plays an integral role in multiple national priorities, including returning humans to the surface of the moon. SpaceX and its thousands of employees work tirelessly to ensure the United States remains a world leader in space, and we remain committed to working with our local and federal partners to be good stewards of the environment. Micrometer. The NBC updated its story yesterday with additionally factually inaccurate information. Oh boy. Or there may be a typo in one of the initial TCEQ's public versions of the permit application. The rest of the application and the lab reports clearly states that the levels of mercury found in non-stormwater discharge associated with the water deluge system are well below state and federal water quality criteria of no higher than 2.1 micrograms per liter for acute aquatic toxicity, and are in most instances non-detectable. The initial application was updated within 30 days to correct the typo, and TCEQ has updated the application to reflect the correction. I think so, Jim. I kind of want to go read this article now. Like, can we... Elon replied, CNBC sucks. All right. It's not Mike Sheets. Yeah, yeah, okay. Where... I want to read the article. I'll click on the article so you don't have to, okay? Now I'm curious. Where's that CNBC article? Hold on. CNBC SpaceX water. Let's see. I got it, fellas. I told you I'd find it and I'd click on it so you don't have to. Elon Musk's SpaceX violated environmental regulations in releasing pollutants into nearby bodies of water in Texas, a state environmental agency said in a notice last week. The report from TCEQ came 5 months after the EPA also notified Space. The violations could threaten SpaceX's ambitions to increase Starship. All right. To be fair, SpaceX is Gwen's. Cope. Elon Musk's SpaceX violated environmental regulations by repeatedly releasing pollutants into or near bodies of water in Texas. A state agency said in a notice of violation focused on the company's water deluge system. Okay. The notice from TCEQ last week came 5 months after the EPA agency Region 6 office, which covers Texas and surrounding areas, also informed SpaceX that it violated the Clean Water Act with the same type of activity. The notices and related investigative records obtained by CNBC have not been previously reported. TCEQ said its agency's office in South Texas in the South Texas city of Harlingen, near Starbase in Boca Chica, received a complaint on August 6, 2023, alleging that SpaceX was discharging deluge water without TCEQ authorization. Received a complaint. Gee, I wonder who that came from. In total, the Harlingen region received 14 complaints alleging environmental impacts from the facility's deluge system. Aerospace companies, including SpaceX, generally need to be in compliance with state and federal laws to gain approval from the FAA for future launches. SpaceX was seeking permission to conduct up to 25 launches and landings of its Starship spacecraft and Super Heavy rocket from its Boca Chica facility. Notices of violation could delay those approvals and result in civil monetary... Okay, yeah. In a lengthy post on X following publication of the story, SpaceX said regulators have told the company that it continue with operations despite the violation notices. Throughout our ongoing coordination with TCEQ and the EPA, we have explicitly asked if operation of the deluge system needed to stop, and we were informed the operations could continue. Yeah. Neither regulator answered CNBC's question regarding SpaceX's statement. Wait, they edited this mid... On July 25th, 2024, an environmental investigator with TCEQ conducted an in-house compliance record review to determine SpaceX has complied with wastewater regulations. The investigation found that SpaceX discharged industrial wastewater without a permit 4 times between March and July of this year. No, they didn't. All right. Water deluge systems with flame deflectors diffuse heat, sound, and energy generated by orbital flights and rocket launches, but SpaceX didn't build that system into its launch site in Boca Chica before it began to do test flights of the largest rocket ever, Starship. SpaceX is developing Starship to transport... Why was that pertinent? All right. SpaceX is developing Starship to transport people and equipment to the moon, and if Musk eventually realizes his grand vision to colonize Mars... The first test flight of Starship in April of 2023, energy from the rocket caused SpaceX's concrete launch pad to explode, and its spacecraft also blew up in midair. Chunks of concrete were hurled into a nesting and migration site important to some endangered species nearby, and a 3.5-acre fire chewed through Boca Chica State Park land south of the launch pad. In response, the environmental groups filed a lawsuit against SpaceX and the FAA, which has authorized its launches. With Musk pushing for another orbital test flight within 1 to 2 months, SpaceX rushed to rebuild the launch pad, installing a new water deluge system to keep it from exploding again. The company bypassed the permitting process according to regulators, which would have required it to meet pollutant discharge limits and say how it would treat its wastewater. SpaceX ran its first full pressure test of the deluge system in July 2023. About a month later, on August 25th, EPA initiated a probe and requested information from the company regarding its wastewater discharges and more. The agency issued a formal notice of violation to SpaceX on March 13th, according to records obtained by CNBC. On March 14th, despite receiving the EPA notice a day earlier, SpaceX pressed ahead with its third test flight of Starship, again using its unauthorized water deluge system at the... Okay. The company hit new milestones for the test flight, and Musk appeared triumphant. NASA Administrator Bill Nelson congratulated SpaceX on a successful test flight, although the rocket was lost during its descent above the Indian Ocean. Yep, here we go. Here we go. Yep. 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 Yeah, I'm not including that. You guys, if you want to read that, go ahead. I'm not saying that part out loud. Once the agencies had informed SpaceX it was in violation of environmental regulations, continuing with launch operations at Starbase put the company at greater legal risk. Further wastewater discharge could trigger more investigations and criminal charges for the company or any people involved in authorizing the launches. It's ESG Hound Element, the guy that made a big deal about this in the first place, and he seems to keep making a big deal out of this, even though it's not really a big deal. But he seems to think he knows more than the EPA and everybody else and SpaceX about their own rocket deluge system. And because he's a contrarian opinion, a lot of mainstream news picks it up because, take a shot at the king, right? That's what's going on here. Like, am I interpreting this wrong, fellas? I'm pretty sure I'm on par here. Yeah, that's right, floating. Yeah. Kenneth Teague, a coastal ecologist based out of Austin, evaluated the 483-page SpaceX permit application. Teague, who has more than 3 decades of water quality and coastal planning experience, told CNBC the application was full of holes, missing basic details about water discharge volumes, the temperature of the effluent and outfall locations. Teague said he's especially concerned about the concentration of mercury in the wastewater from the SpaceX deluge system. The levels disclosed in the document represent very large exceedance of the mercury water quality criteria. According to the U.S. Geological Survey, mercury is one of the most serious contaminants threatening our nation's waters because it is a potent neurological poison in fish, wildlife, and humans. He said the temperature discharges and pollutants like mercury in high concentrations could cause significant nerve impacts. Yeah, mercury kills things. Thank you. Thank you for the update, pal. SpaceX application fails to address this very serious concern. SpaceX said in its response on X that there were no detectable levels of mercury found in its samples, but SpaceX wrote in its July permit application under the header-specific testing requirements, Table 2 for outfall 001 that its mercury concentration at one outfall location was 113 micrograms per liter. Water criteria in the state calls for levels no higher than 2.1 micrograms per liter for acute aquatic toxicity and much lower levels for human health. CNBC reached out to the FAA on Friday. The agency didn't provide comment for the story, but announced on Monday that it's postponing public meetings. Yeah, that's another thing we got to discuss. CNBC reached out to the FAA on Friday. The agency didn't provide a comment for this story, but announced on Monday that it's postponing public meetings that have been planned for this week. The meetings were for an environmental assessment for SpaceX's plan to increase the launches and landings of its Starship Super Heavy vehicles scheduled at the Boca Chica site in Cameron County. I want to go back to see what they said about Mercury here. Get this, 113 micrograms was... Get this, 113 micrograms they quoted was because of a missed decibel in the photo scan. Oh. Yeah, it's in their comment. We just read it. I'm just... Yeah. Okay. Yeah, it's right here. Well, Tessa, that environmental engineer was basing his entire thesis off of that typo. So, I mean, the guy also said there were glaring holes, whatever that means. I mean, what would the source of mercury be? It seems logical to assume it was a typo. Yeah, well, I mean, Pete, I'm not going to sit here and pretend like people don't throw that out the window, the logic out the window to make a good story nowadays, you know? That's no secret. Yeah, so... See, I'm not... It seems like SpaceX has all their T's crossed and their I's dotted. It very much seems like they got a general permit, right? They got a general permit from TCEQ about water discharge, right? You got a general permit, and then they built the system, and it worked, and then the EPA, somebody complained to the EPA looked at somebody, I'll bet you it's somebody. And then the EPA went and looked at it and said, everything seems okay here, but you probably want a specific permit, an individual permit, not a general permit, because this is, not everybody has launch deluge systems in Texas for their rocket launch pads, right? So it'd probably be a good idea to get an individual permit, and it looks like SpaceX did, and everything's good. Did I miss anything here? Yeah, Pete, that's my big thing. 0.113 is probably what it is. Like, where's this mercury coming from? You have potable water being mixed with methane, being mixed with potentially, well, combustion byproduct remnants of methane and oxygen. There's no mercury in this equation unless it's background, unless it's coming out of the ground. Like, there's no mercury here. This is not rocket science. You missed a bad CNBC journalist with a bone to pick with SpaceX. If there's any bet, I'll bet it came from the ocean. Yeah, maybe. Yeah, that's what I mean. It'd be background, right? Like, That was the one hard fact in the whole article, and it was a typo. Doesn't seem like anything's wrong here. I'm pretty sure, if anything, guys, this is hard to judge what this deluge system is going to do because it's the first of its kind. How are you gonna know? How are you gonna know until you go and test it and do something with it? Which is, once again, that explains the general permit from TCEQ, right? And then somebody complained to the EPA. The EPA went to look at it and they said, yeah, this seems fine. Just get a more individualized permit so the nomenclature is fine. And once again, CNBC is working. They seem to base that entire article off of the permit submission from SpaceX, which means this is what SpaceX wants to do with no input from the EPA, implying that that's gospel. The submitted report is gospel, which is see, a permit application. Permit is what you want to do. And you send it to these people and say, this is what I want to do. And they say, no, you can't do this, and this. Writing an article stating that SpaceX is breaking the law based off of their permit applications, and then having environmentalists look at this permit application and say they're breaking the law based off of that is not a good way to report the news. That's like grading somebody's test on a first draft. It's a permit application. That's this. There's no story here. There's no news here. This is just. There's no news. I mean, the only thing that you can really write this off of is that somebody at CNBC has a bone to pick with SpaceX. I mean, that's the only thing I can really think of here. Like, why would you even bring this up? And why would you cite people that have no familiarity with the issue as sources as to why this issue is bad? You know what I mean? It doesn't make any sense. Like, this is not science. I don't like covering stuff like this. I've decided I'm not doing this anymore. There's an upgraded draft environmental assessment that SpaceX submitted the other day. It will get approved and they will launch. Their deluge system is fine. Dishonest is the word I think you want. You know, it just goes back to what I was saying. Like, you can like SpaceX, you can not like Elon, that's fine. But don't conflate the two. You can say he's a jerk but still think SpaceX is cool. That's totally fine. I think, you know, it's like it's high school or something, man. But to try and insinuate that somehow SpaceX is succeeding in spite of him is a little crazy. That's ridiculous. That's not what's going on at all. All of the author's other pieces are all hits against months in his companies. Yeah, of course, Jax. Yeah. Why did SpaceX decide to respond more lately? I think because they're sick of the nonsense. I think SpaceX is very much worried about an article like that gaining traction and it influencing people who make decisions when it comes to this stuff. You read their article, that means they win. Clickbait, negative stories sell. Yeah, okay, that's fine, Jib. If they want, I'll take that exchange so you don't have to, right? But also, I'm gonna sit here and say that the person that wrote that is a fucking moron. Look, man, you can put the article out all you want. That does not save you. That does not absolve you from judgment by your peers. I'm sorry, it doesn't. I would hope people do the same with me. I'll take my time out. Okay, timeout over. I'm not saying no more about this. I don't need to say anything else. This is a nothing burger. Have fun with that. Anyway. Yeah, Wisp, all I can do is just present people with facts. That's it. That's all I'm going to do. And it's not like, oh, facts are the best thing in the world. No. Look, man. People make something out of nothing. They make mountains out of molehills. It's a little ridiculous. I'm not gonna lie to you. I'm getting kind of sick of it, which is why I don't want to be a part of it anymore. You know, a nothing burger. No, Exo. In this particular case, I probably would agree with what Eric Berger has to say about this, because he loved, that dude loves SpaceX, and that's fine. I do too. Yeah, there you go, Dink. That's it, man. Trade 1 for 500. I'll take the deal, and I'll be able to. So, like, okay. Swearing aside and saying that person is an idiot aside, right? Here's the thing. I know now that I can't trust that person. I can't trust what that person has to say. They violated their own journalistic integrity in my eyes, right? I've been watching a press corps for years, okay? Years, a decade, pretty much, a little over a decade. I know who writes these articles, and I know who doesn't. Very careful about who we take sources from for this exact reason. You know? Anyway, next bit of news. Check this out. Sierra Space posted this video. They did another burst test on their Life 285 module. The Life 285 module is an inflatable habitat module that what Sierra Space is actually working on now is making a multi-axis inflatable module. What does that mean in plain English? Docking ports on the inflated parts of the module, because in the past, the inflatable modules really only had a docking port on this side and this side, or at least any plans for them. Sierra Space is working on integrating a docking port fixture on the radial axis of the port. That's what this test is for. The Life 285 could have a grapple point for a robotic arm. It could have a docking port. You could have a window. You could have an airlock. You could have whatever you want. The crazy thing is that this is on an inflatable module, which is actually super cool. Here, anyway, you want to make sure that this thing doesn't pop in space. So to make sure that that doesn't happen, Sierra Space has done this. Yeet! 60.8 psi, result 74 psi. That's a little bit of an over margin there, but hey, good. No sound. Yep, nothing. That's destructive testing, baby. So they're testing at 70 psi, which is like, what is that, 4 bar? Which is well above what you'd ever see inside of any spacecraft module ever. Modules up there are 14.7 psi. And we're looking at so you got to think about what's your pressure differential here. 14.7 psi on the inside and 0 on the outside. That gives you a 15 psi, give or take, rounded delta there between inside and out. This thing is rated for 4 times that. Yeah, that thing ain't popping. It's not popping in space. The next thing I think they should do is shoot spuds at it, but whatever. Maybe they'll do that. What would it feel like to be in 60 psi? Weird. Three bar is 45 psi. Yeah, this thing is way over-engineered, but that's on purpose because. Why would you over-engineer it to that margin? Well, you'd over-engineer it to that margin because it's an inflatable module, right? Like, I mean, one, it's a crew module, but right with this inflatable. Yeah, you know you're never exceeding that. You're never. Look, man, if you're exceeding that if your internal pressure passes 4 bar, I'm pretty sure the last thing you need to worry about is your module popping, because that either means A, your environmental control systems have had a catastrophic depressurization and you need to get the hell off the space station anyway, or your space station's on fire. In which case, the module bursting is the last thing you need to worry about. You need to leave. You need to leave. Which is why they chose those margins there. You're never dude, if you encounter 4 bar inside of a module on a space station in space, you got a big problem. Run away. You want it to pop at 420 psi. Okay. Just joined. How does that do with micrometeorites? That would probably be something. That would be my question, dude. How is it going to do with micrometeorites? You're going to need to shoot bullets at this thing. Actually, micrometeorites should be going faster than bullets. Yeah, you need to just see what it does. Yeah, Sassor, I guess it depends, right? Anyway. Humans can live in hundreds of PSI if transitioned slowly. Yeah, there you go. 4 bars. My diesel will only do 1.5 bar boost. Nice. If I recall correctly, there are NASA facilities that have super high-speed pew-pews. Yeah. Yep. Oh. Yeah, this is the next bit of space news that's going to affect our schedule a little bit tomorrow. So check this out. NASA, yeah, thanks, Jim. I was going to talk about it. I had it kind of linked up here. NASA is going to give us another update on what's going on with Starliner tomorrow at 1 p.m. To provide an update on the agency's Boeing crew flight test mission. Mission managers continue to evaluate Starliner spacecraft's readiness in advance of decisional meetings no earlier than next week regarding the return of NASA astronauts Butch Wilmore and Sonny Williams. Participants include Ken Bowersox, Joe Montalbano, Rush DeLoach, Joe Acaba, Emily Nelson, Chief Flight Director, NASA Operations Flight Directorate. Where's Steve Stitch? And Mark Nappy. Huh. That'll be an interesting conversation. So that's going to be tomorrow. So we're going to start off with space news tomorrow, and then, yeah, I'm not sure what we'll do from there. There's no rocket launches. The range is clear today and tomorrow. Progress MS-28 goes off at 11:20 tomorrow. Interesting. Okay. So I've been out of the loop on Starliner, but have they said anything about another test flight before operational missions? You have no. You finish this test flight, review the data, make your decision based off of that. Did I hear that it may block a docking port permanently or press hyperbole? I don't know who the hell reported that box, but they need to immediately stop writing about spaceflight. Yeah, like immediately stop. It'll never permanently block a docking port. The docking, even if Starliner is a brick, right, and they shut it off and they shut it off and it's a brick, you can't do anything with it. The ISS docking port that it attached to can dump it. The docking ports that NASA uses are NDS. They're NASA docking system. That's derived from the International Docking System Standards, which is based off of APAS 95, believe it or not, a Russian docking port, or at least something very similar to it. APAS are androgynous ports, so basically, even if one port is completely passive, the other one can latch to it. In this particular case, the ISS could dump Starliner if it really needed to. If it really needed to. Whoever wrote that knows nothing about anything that I just said. It wouldn't surprise me if they keep it under 1 bar and have some of that self-healing goop in between the layers. I mean, just maybe, I don't know. Yeah, Exo. There's a lot of bull crap to wade to get to the good space news, but yeah, that's what I'm trying to do here. I'm trying to not get involved with that. That's my new thing. I'm not being a part of this. I'm not doing it. Not doing it. I'm just sticking to technical stuff, man. With that being said, check this out. Astrolab, who has a contract to build a lunar rover, posted this. I might have to mute this because of DMCA, but here. Nope. We're copyright free. All right. That's pretty coggers, dude. Yeah, I would assume that then the inflatable modules work like a bulletproof vest, dude, right? Like, that doesn't look like a Ford Raptor. It's Ford Raptor from a parallel timeline. So this is Astrolab. They very clearly have a pretty high fidelity model of their rover that they want NASA contracted them to make, which is actually super cool. Now give it to Whistling. Give it to Whistling. See how it holds up. I'm not sure that's a good idea. Anyway, that's pretty cool. I like what Jim said. Oh, that's really neat. Wonder when they'll cancel it. No comment. No comment. That Cybertruck video. Dude, okay, so I like Whistling. Been watching Whistling for a long time. The reason why that Cybertruck bumper broke is when they drove it off those concrete cylinders, the concrete drainage pipes, it sheared the bumper. Like, you could see it shear the bumper. You know why? Bumpers are designed to take load on their long axis, not on this axis. So they're designed for tensile strength. They're designed for tensile strength, not shearing strength, because it's a bumper, it's a trailer hitch. You did that with any truck, it would do the same thing, man. Probably worse. Yeah, you know, I mean, okay, so just think about it like this. How much does Cybertruck weigh? Cybertruck's like, what, 6,000 pounds or something? It's something absurd, right? So you have 6,000 pounds of force pushing down on that bumper, on a bumper that's rated on a completely, that's perpendicular to its 10,000 pound axis load, right? Basically, if this is the truck, right, this is the back of a Cybertruck, your bumper is right here. Bumper is designed to be pulled. It's designed for tensile strength because you're towing things, right? When you hit it this way with basically half of its rated load on a perpendicular axis to what its load rated for, yeah, it's going to break. There's not many things that would survive that in one piece. That would be like, I don't know, trying to fly like a 747 backwards. I don't know what's going to happen. It's probably not going to be good. And yeah, flying backwards generally isn't what you want. 7,000. There you go, Sea Kraken. Yep. He was pulling. No, not. Well, Rocket Guy here. All right, let me show you. Look, it's right at the beginning of the video. So if you guys want to go watch Whistling, do it. I like this dude. I think this dude's funny as hell. I mean, he breaks stuff, but whatever. All right, so check this out. This is the beginning of Cody's video right here. Take a look. And once again, this is not saying that his review is not good. A lot of the other tests that he did were actually pretty rad. So I thought it would be here. Watch, just take a peek. Actually, the intro to this video is pretty freaking cool. They compared a Cybertruck to an F-150. That right there, Rocket Guy, that's what I'm talking about. They did that towing test after this. Watch the rear bumper. Boink. You see that? It was quick. Yeah, see that? That's not good for it. That right there. There's a point where the entire load of the Cybertruck is basically applying a shearing force to that bumper. Yeah, there's not many trucks that would be happy after this. You see that? So Cybertruck's bumper and its receiver in the back is all cast. It's cast into a subframe, right? And there's no way that didn't crack that casting. There is not a chance in hell that didn't crack that casting. 7,000 pounds of shear force is being applied. Well, it's maybe not 7,000 because the front wheels are touching, but the front wheels are on the ground. But clearly that's like here, boink. Yeah, that's not good for it. Anyway, I do like Whistling. Whistling's an awesome YouTuber. It's a funny dude. The guy makes me laugh. One of his other videos, he bought a turbojet engine and strapped it to a merry-go-round. Yeah, that ended about as good as you. No, I'm serious. Like a real jet engine. The guy's playing Kerbal, and he's playing Kerbal in real life. It's really funny, actually. The Ferrari videos. I don't think he meant to do that one, Panda. I don't think they meant to burn that Ferrari to the ground. I'm pretty sure that was not on purpose. Giga castings are unknown repair territory. Yep. Challenger on carriage wheels is pretty funny, yeah. There are some concerns like repairability if you ever crack the casting. Everything people have shamed it with has been dumb so far. If you want to criticize Tesla, do it for an honest reason, like their corrosion problems are cracking the suspension. Aqualux, yeah, I mean, sure, if you want to go with all that. Personally, I think Cybertruck is performing pretty much as advertised. There are some parts that are a little cheap if you look at the rest of Whistling's video, like when he shut the doors, look what happened. Like, you should probably fix that. But in terms of like being an armored personnel carrier, Cybertruck pretty much lives up to that. It's pretty damn good at it. Like they beat the crap out of that damn truck. And they beat the crap out of the F-150 too. The F-150 did pretty well. I was pretty happy with that. You know? You're slightly defocused. Isn't the point of a casting to be cheap, high volume? But yeah, I mean, my big thing, Aqualux, with Tesla is that they're not right to repair. So you guys are talking about, oh, can you fix it if we crack the casting? Tesla ain't going to give you another casting. That's what I mean. I'm not cool with that. Like, if you break your truck, that's it. Not okay with that. You should be able to repair the thing that you bought. It's yours. That's my big thing with Tesla. I think that's a fair criticism. Other than that, I think Cybertruck's really cool, to be honest with you. They beat the crap out of this thing. They had guys just take sledgehammers to it for like 20 minutes, and it was like, and they were sitting inside going like, dude, I'm telling you, watch that video. It's crazy. There are plenty of real problems to point out about Teslas without making up stories of them catching on fire. Yeah, Bill, it's funny. All that does is just make them look stupid. Like that CNBC article. That's a really good example. Tesla, Apple, John Deere. Is there a difference between them? Nope. To be fair, no car company is pro right to repair in this age of time. You have no idea what you just said, Sebi. To imply that Tesla is as anti-right to repair as Ford or Chevy or any other automotive manufacturer is absurd. I could buy a Toyota from 1973 right now and go to any Toyota dealership and get a part for it. Any Toyota dealership, ever. Any car. Any car. Toyota stands behind their product. Right? And I'm saying that as Mr. American Truck over here. You could go buy parts from the dealership for a 73 Corolla right now. With Ford, it's back to the 80s. I could go buy brand new parts for my 97 F250 at the Ford dealership right now. I could walk in and be like, I need this part. And they'll be like, okay, cool. We'll get it from the warehouse. We'll have it for you in a week or a day or whatever. Right? Any part, anytime, any dealership. You absolutely cannot do that with Tesla. No way. 1973, not a 2023. Okay, you're not listening to what I'm saying at all. That's fine. I'll just keep going. What else do we have? Toyota, Ford, Chevy are more exception to the rule, to be honest. I can't get parts for your 97 BMW bike. Well, that's on you for buying a crappy bike manufacturer. So how's that my problem? You guys are saying not most people is right to repair. I give you plenty case examples of cars being, of automotive manufacturers being pro right to repair, and you say, well, no, not like that. What? I'm confused. If you're talking, Seb, the only thing I can really think of is that you're talking about the design of cars nowadays. The design of cars, yeah, sure. But that's not necessarily anti or pro right to repair. You could still buy parts for these cars. That's what right to repair is all about. Is it a pain in the butt to fix a new car and replace a part on a new car? Oh yeah, absolutely. But that's not anti right to repair. That's just annoying. But you can still go buy the parts. That's the difference here. There's no, if I need a new drive unit for my Tesla, I have to take it to them and they have to do it. I can't do it myself. You don't have any option to fix your vehicle. You can't go to Tesla and buy parts wholesale. That's no. Dude, I like Teslas. I think they're cool cars. I'm not going to buy one because of that. And it's a shame because I really like SpaceX and I really like Tesla and all that. I want to support, but not like that. But you die if playing mechanic in a Tesla. I don't understand what that means, Alex, but all right. So yeah, just some food for thought there. Anyway, let's see what else. Yeah, Panton, I'm not one to criticize. I don't have my own automobile company. Just work on cars, dude. That's in no means a deterrence. If you want to buy a Tesla or something, do it. They're great cars. The panel gap could use some improvement, and some of the build quality could use some improvement, but they're getting there, dude. They're getting there. It's definitely better than the quality from like a Tesla from 10 years ago. You know what I mean? I was talking about the fixability mostly. Your average Joe can't fix a modern 2024 Ford Mustang by themselves when it has electronic problems. Yeah, but of course you can. You can, but the part is there. Like if you wanted to, the part is there. That's what I'm saying. Tesla has no aftermarket support. Nothing. No, there's not even first market support. You can't buy Tesla parts wholesale. That is a big problem. I'm not gonna buy. I'm not gonna buy something you don't stand behind it, right? Like, sorry, not doing that. It's not about whether you can or can't, Sebi. It's about the choice in the matter. That's what right to repair is. It's the choice. Even Ford and Chevy with their electric vehicles. I can go to Ford right now and buy a Mach-E drive unit. I can go to the dealership right now, buy one, no problem. They won't even question it. Pay me. Here you go. Have an electric drivetrain. There you go. Done. Yeah, Element. I think that's what we're dancing around. But yeah, just take that. Like I said, take that for what it's worth. That's my criticism of Tesla, and I don't listen to me. I mean. My taste in cars is clearly a little bit out there. Yeah, we'll say a little bit out there. So, yeah, I mean, that shouldn't dissuade you from buying one. I think they're great cars. I think Cybertruck's cool, to be honest with you. I think it's a pretty cool truck. The 48-volt architecture drive-by-wire is actually super cool. Popping in between glasses to say hi. I'll talk to you in about an hour. All right, we'll be here. Honest question. What are your thoughts on the used EV market in 5 years when the market is flooded with EVs with battery degradation? Batteries are expensive, and the most experts agree the price won't go down anytime soon. Oh, what What price of anything is going down? JSpeed. Yeah. In terms of the context of the EV market, I don't know, man. Hybrids. I don't know, dude. I don't think the battery degradation is that big of a deal. Have I seen this? This is Heavy D. Yeah, man. Alien Viper. I saw your link. I saw your link. Yeah, Heavy D, dude. He beat the snot out of a Cybertruck. That's what I'm saying, dude. Cybertruck's pretty cool design. I just wish I could work on it. You know what I mean? If something breaks, dude. If that casting breaks, you're screwed. You have a really nice 7,000-pound piece of stainless steel. The only solution is to take it to Tesla and have them pay for it, in which case they probably won't. They'll just give you another one. I don't like that. I don't think throwaway culture like that is a good idea. That's not, I mean, you're supposed to be sustainable, unless I'm missing something. This is just my personal opinion on it. Not saying Tesla's bad. Teslas are pretty cool cars. I like them a lot, actually. I just wouldn't buy one because of that. Battery degradation is not a large issue. Things like individual cells failing will be a problem, but I guarantee independent shops will pop up that do battery repair. Yep. Cybertruck is cool unless you want to reach a new truck bed from the side. You know what, JSpeed? Here's my thing. You know what the thing about Cybertruck is? At least somebody's trying to do something innovative for a change, all right? It's something. Because it's something. Like, I just feel like we've been rehashing the same design of truck for like the last 20 years. Which is, I mean, all right. Like, you know, because they work. Yeah, I guess. I mean, yeah, there you go. With the regulations that are in place. Oh, you added that to the end, huh? You added that little something to the end of what you said. Oh, that's weird. More importantly, it's not Cybershoe. Tesla makes cars and trucks, caveman. They don't make something that's halfway in between. Yeah, they make cars and trucks. Actually, the Model Y is kind of halfway in between, but hey, whatever. Anyway. Let's see. There's really not much else, guys. Yeah, the cycle is kind of slow today. Ooh. What is this? Hang on. National Reconnaissance Office. Tech Tuesday. Hexagon achieved 19 successful missions with the help of the Titan 3D rocket. Learn more about the rocket that was capable of launching a satellite as big as a bus. Thank you very much. I will. I'm honestly annoyed how hard it is to get anything that isn't a crossover nowadays. You'll get no argument from me, man. Oh, man. Post the rest of the video. Dang it. Where's the rest of the video, NRO? Crap. Sit there and watch that all day. Anything else? Anything else? Yeah, news cycle is a little bit slow today. Did I read last? Going on the end of KSP, a couple people I know helped me out and found this devlog on the revamp KSC. It has a bunch of textures in the link. Oh. Oh, that's B9. Dude, he made that all in SketchUp. Can you believe that? I remember when this thread was freaking posted, dude. Oh, dear. Yeah, he made the VAB in freaking SketchUp. You've got to be kidding me. All right. Yep. B9's good people, dude. I've actually never met him before. Oh, there's your normal map. That's awesome. Yeah, dude, I remember this. Crazy. Yep. Dude, I can do all this. This is not a big deal. I can do that. That's not a problem. It would take a second. It'd take me some time to remember how to do it, but I'm gonna hold on to that thread, dude. Thank you. Anyway, speaking of, let's get the heck off that. That was Bozzy. He was saying something. Speaking of building cars, some French mad lad put a 500 horsepower K20 in a Renault Twingo. Oh, nice. That's awesome. Cool. Yeah, those Honda motors, those K20s, you can do some pretty good stuff with them. They're pretty good little engines. The K-Series is always a good motor. But hopefully this helps expedite texturing. Yeah, we'll see. Yeah, exactly, Goat Man. What these just randomly pop up in my following feed by people that I'm not following. I'm not upset. What the actual hell is going on? I feel so bad for that girl. Oh my goodness. But also, man, it just what do you what? 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 Oh, okay. I blinked. What happened? Nothing. Don't worry about it. Nothing. It's fine. It's fine. Let's see what's going on with our buddies over at NSF. It's fine. Trust me, they're fine with it. Nothing. Oh my goodness, that's awesome. Have you seen the new Renault 5? It doesn't actually look that bad. Is it a car? Yeah, that's pretty neat. That's pretty neat, dude. Yeah, not bad. Seems like they enter over a short little history playlist on YouTube. Ooh. Ooh. Oh, sick. Oh, that's actually super cool. Good find, Hill Hydra. Ship 26 move. That's right, Sean. Yeah. Let's see. Let me see something. Here we go. Hang on, I need to check something. I probably shouldn't do this, but this is Flame Trench, any real quick. Yeah, T45 Go Shock. There we go. Are they finally scrapping Ship 26? Oh, I hope to. I hope so. John, you said you... Okay, I went to YouTube and found it kind of funny. Oh, okay. Oh, man. Alex is getting a lot of flack in that town. Frick those people, man. I like Alex. Control F EJ? Nah, shouldn't read the comment section like that, dude. I'll just be prowling for haters, go and yell at them. Anyway, let's see what's going on with the down in Starbase. This footage is coming from Starbase Live from our buddies over at NSF. Guys, please go over there and support them, please. Good stuff. There's that crane dolly. They're bringing the crane down to fix those stabilizers, no doubt. The boom to jib stabilizer on this crane snapped the other day. Also, look at the dolly. The dolly for the crane compared to the car next to it. Camaro. Yeah, that dolly is not small. Yeah, the stabilizer snapped. Let's see if NSF has some footage of them taking it apart. During the last Flame Trench, you did some cheer and clap thing while saying identical. Was that a reference to something? It's a reference to my cousin Vinny. Ah. Yep. There's your stabilize. Oh, ho, 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 ho. Whoa, ho, ho, ho. I couldn't explain the reference. Ah, identical. There's that one, that part is not like the other part. Yeah, that's broken. This is a... No, the CC8800 isn't a Liebherr crane. Wear and tear or overload? Don't know, Tessa. Yeah, I'm not sure. The CC8800, it's not a Liebherr crane, pretty sure. Yeah, that thing's very broken. It's a Saren's, that's what it is. Thanks, Sean. Yeah. I wonder if it damaged the flange. See these things right here, guys? This those are pendants. That's what I was talking about. These things are the pendants. They kind of just hold parts of the crane together. I wonder how much dollars it is to repair that. I don't know, but they're taking the other stabilizer bar off. You got to push a pin out with a hammer. Oh, that's a boom stop. Yeah, that's, well, it did. You got the boom part right. That's broken. Yeah, that's. Those sides look okay. That clevis looks fine. That's an easy fix, right? Right? Those stabilizer bars are probably not cheap. Those are probably not cheap. Yeah, if one sheared, the other one would, yeah, snap. It's Windows!
How much do you think Microsoft Windows is worth? Wait just 1 minute before you answer.
And listen to this incredible music!
Windows.
Alright, that's enough. Delete that? No. Rocket Garden, ship 30, 26. What was the other ones? 32 and 20. What the heck they're gonna do with 20? They gave out with some force, see some charring when it let go. Yeah, that's it's expensive. Just when it was out of my head, you put it back in. Sorry. My bad. SpaceX could use a lawn ornament for the new Texas HQ. I don't know how you're going to get Ship 20 to Bastrop, but yeah, sure. Hey, wait a minute. Let me back up. Back up there. Yeah. Kuka. See the robotic arm? I think Kuka, Sebi, but I'm not sure. It looked like the Kuka ones that we saw come in here a long time ago. That guy's really high up in the air. Just thought I'd let you know. They didn't have 2 new stabilizers, so only one is being used right now. Huh. Okay. Oh, nice 5th wheel, dude. Hell yeah. Oh, yep, there he is, bringing in that. There's the stabilizer. It's on the 5th wheel. But that trailer has 4 wheels. Yeah, and the 5th one is the pivoting point. Oh, nice maneuver. That's the 5th one. There's a 5th wheel right there. There's 4 over there and there's 1 there. That's not how that works. It's the 4 wheels on the truck and the 5th wheels in the bed. Yeah, those, see that? Yeah, those are broken. Yeah, that's not how that's supposed to be. It's Kuka. Tesla also uses Kuka. Yep. Telescopy boy. Cool. I bet it gets fixed and put back into service. I mean, it's a cast part, dude. Maybe. Maybe the outside of the cylinder, sure, but not the movie part, the shiny part. No. Junk. Get rid of it. Scrap. Oh yeah, look at the little bumper pads. Huh. I'd have to, I need to ask Alex what the heck is all this stuff. I haven't been keeping up, like, for the longest time, dude. I wasn't keeping up with any of this stuff. Interesting. Like, what are these cylinders for? Anybody know? Those are the pistons that move the rail up and down. That is a big gusset plate. Whoa. That thing is real heavy. Whoa. And they're still not painted Apollo red. Dude. So those are reinforcement. They're reinforcement brackets. Reinforcement plates on the joints here. So the tower doesn't flex this way. It doesn't move. Because I have a feeling that a lot of mass is going to get added to this tower in the future very quickly. Dude, you're going to need a hammer wrench to freaking just put all those things together. They are the pistons that actually push the rail. Okay, Ringtone. Thank you. Yeah. Dude, there was a time where I could tell you every component on this thing. Not that ship sailed a long time ago, dude. But hopefully we'll get back to it. And they should be putting this one on the other side. They have this plate piloted on a couple of holes right there. They're going to put this one on the other side. And we are not going to see it. That looks like good old Victorian bridge construction. They're not riveted, though. They're bolted, dude. Yep, that's what Jack was talking about in the update video yesterday. Where they're extending Star Factory. During the Raptor side. Oh, okay, Foz. Yeah. Dude, I still can't believe they took a flap disc to the front of a freaking spaceship. I'm sorry, that's just... Those are flap disc marks. See all the squiggly lines up there? Somebody took a damn flap disc to that thing. That's just... They took a grinding wheel to it, which is just... That still is weird to me. It's just stainless. I know, but you wouldn't see that anywhere. There's already a song about the Mechazilla slap. Oh, jeez. Why wouldn't they? Yeah. Oh. One thing that I've always said, guys, is if you want to know if a test flight is on the horizon, start to see if the propellant truck starts showing up on Highway 4 in these videos. If the propellant trucks are showing up, you're getting ready to use something with propellant. I know. Weird, huh? SpaceX craft are delicate flowers. Meanwhile at SpaceX. Spacecrafts are delicate flowers. Meanwhile at SpaceX. Yeah. Oh, there we go. Dude, it's got one stabilizer on it. Is that okay to do? I mean, I guess it's okay to do. Look, I'm looking at it. Yep, they removed the dolly, and now what they're gonna do is take the boom and do that. Watch. Yep, there it goes. Bring that up. All right. Next module. Did it? The guy in the side by side is in reverse. The side by side is in reverse. What? That's only 2 levels, aren't there usually 3? This is the top. That's the top of the tower, Jim. Yeah, there's, or at least I think it is. It's not like the very top. There's a piece that goes on top of it, I think. Nice. 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 This is 7. There's still 8 and 9 in Sanchez. Last segments are smaller. Yeah. Okay. It's the bottom of the top then. Yeah. Didn't realize they were that close to the end of stacking tower 2. Yep. The gator went backwards the entire roll. Dude, I saw that. Yeah, Ringtone, I saw that. Module 7, 8, and 9 are only 2 levels. There you go. Okay. Yeah. Interesting. I wonder why. I wonder why you would do that way. I'm sure there's a good reason, but it's the beginning of the end. On Tower 1, segment 7 was 3. Yeah, that's what I'm saying. I don't remember that being like that, but they must have learned something from the first tower, and it must have made more sense to make those things in smaller segments. Weight and height, maybe? Sean, that's my guess. I'll bet you it's easier for the crane. That's my guess. I'll bet you it's easier for the crane to move it around. I want to see that crane go up again, man. Dude. That seems like the configuration for that thing until the very end, until the stack is done. Then maybe they'll add one more, but it's hooking up the load spreader for the new module right now. Oh, sweet. Let's go take a peek. You can see live views from Starbase all the time. Oh, yeah. Could also earn cash on whatever the hell that was. Yep, there's the load spreader. Yeah, go over and subscribe to NSF, dude. They got live streams. We got live streams 24/7, baby. The current configuration is the tallest it will be. Thanks, Ringtone. I'd like to point out that thing right there probably weighs more than that thing right there. See that thing right there? I bet you it weighs more than that truck. The only time I've seen a crane this size is for constructing wind turbines. Cool. Side by side. Probably weighs more than, I bet you, what do you think? All 4 of those trucks? That thing is heavy. It's cast. That thing's not breaking. Configuration 1 was 468 MSL. Config 2 is 574, and config 3 will be smaller than 1 per the FAA. Oh, right on, Ringtone. Thank you. You think config 1 will be for building the orbital launch mount, or config 3 will be for the OLM, whatever they're, you know, stack the tower first. So config 1 is big, config 2 is the biggest, config 3 is a little bit smaller. Yeah, probably. I mean, that makes the most sense. Yeah, that thing is weight. Ew, Jeep. Yeah, I agree. Bep bep. MJep. That is a big freaking crane, dude. I know I say it pretty much every time, but that thing is a monster. Looks like they're going home for the day. Yep, yep. I'll throw you a ping in the NSF Discord with the link to that PDF. Oh, dude, hit me up. Tag me. Hello, pedongles. Dude, is it? Oh, I was gonna say it's a little bit early over there. No, it's like 8. It's like 8 in the morning. My name Jep. My name is Jep. My name Jep. My name Jep, not Jeff. My name is Jeff. See? Oh, hi, did I miss anything? I know I said I wouldn't get caught up with bad journalism, Hokey, but I have no, let me just say that I have no confidence in CNBC for saying anything viable about SpaceX as an article ever again. There's that. Sierra Space tested a new inflatable module, a destructive test where they blew it up at like, I think it was like 4 or 5 bar, which bodes pretty well considering it has radial plates on the inflatable part that you could put a docking port on, which is super cool. That's super neat. SpaceX has repaired the Saren's crane. That's what we were looking at here. Yuck! 113 months party parrot. If you ever visit, I just found a place that does all you can eat Goyuza for 3,000 yen for 2 hours. They just keep bringing it out to you until you ask them to stop. Also includes all the drinks you want. We have to have a Goyuza eating competition. That pronunciation. I don't know, man. Dumplings. Amazing dumplings. Gyoza in English. What kind? Chicken or beef? Pork, you'll lose. You'll lose. You will lose. Pork and shrimp. Do they have beef dumplings? Not this place, just pork. Yeah, you'll lose. All you can eat, dude? Bro, I'm American. I don't think you want to open that box. What do you think? Dude, I'm American and an Italian ethnically on top of that. You sure you want to play this game? You sure you want to play this game? I don't think you want to play this game. And it's pork dumplings. I'll bet on that. You don't know me? Okay, guy. Yeah, drank under the table by an 80-year-old Japanese man. Yeah, after 16 rounds, Tessa. Bro, you'd do 5 and you'd be on the ground. You do know me. You don't know me. You do know me. Why does Australia always have beef against the U.S. in sports? Look at how that. And you said beef. It's doubly funny. Yes. Last night was 65. I think if I skip breakfast, I could do better. 65. All right. All right. Beep. Do you think the crane failure was related to the 30 minutes of guy wailing on the crane with the sledgehammer we saw? Yeah, that may have had something to do with it. But then again, you need a sledgehammer to put that thing together. It's an adult mechano kit or a Rector set. My English isn't very good when it comes to food. What are dumplings? Are you familiar with pierogi? O10? It's kind of like that. Dumplings are like an Asian version of ravioli. Changed my mind. Pro tip, you can't. You dick predominant. Now I'm hungry. I'm getting Chinese food tonight. Hell with this. I'll get Chinese food. Wonton, yeah. Yeah, okay, that's fair. The meat sweats. Ravioli, I know. Dumplings are kind of like ravioli. Same idea. It's just what's inside of it is different. Like a dumpling, a pork dumpling will have pork, a bunch of other things in there. Relevant to the topic. I can't. I can't. Oh my god. Oh, jeez. Oh, ringtone. Thanks for the link, dude. Oh yeah. Oh yeah, let's go. Does it show the configurations of that crane on there? I will give you a horns emoji for linking that. That's a horns emoji reaction. It's not loading. Maybe if I push the button harder, it'll do it. I got the Windows song stuck in my head. Loads fine for you. It loads fine on one of my computers, but on the other computer, I get that. All right, fine. We'll do this way. Yeah, baby. Yeah, I got you. I got you. Cool. Still, just this screen. You know, that's good. Screens are good. Do. You like dumplings, you would love Schweiban Maultisch. Yeah, okay. Any updates on Starliner? Hokie, we got a press conference for tomorrow at 1. So, yeah, we're going to do a shifted around schedule. NHL goalies when they don't know where the puck is. Sent me something on Discord related to the crane. Oh, the manual for it. Yes. Thank you. Note to self, tune in at 1 p.m. Eastern time. Yes. Twitching, I think I used to break it better than that when I was younger. Admittedly, you had epilepsy. I really wish I didn't read that out loud. I really wish I didn't read that one out loud. Yeah, it's heavy. I'd probably eat those. Oh my god. It's so screwed up. That's so messed up. Yeah, ringtone, I saw it, dude. Yeah, I saw page 3. We're good, man. We're good. Oh, God. Okay. All right, dudes. News cycle is a little bit slow today. So I think, do you guys hear that? Do you hear that? I did see the Astrobotic rover, yeah. Thanks for the quick summary. All good, man. Can I do the dance? Like, right? Like, that's the dance, right? Not as bad as Jack with the... That was funny, yeah. More kitty paws? No? Alright. Nailed it? Alright, cool. We're good. We're good. Doing it again. Hey. All right.